All of you please listen. This is the continuation of the previous class. I don't want to repeat what we studied in the previous classes. Okay. We are studying the defects of eye. You can see the screen, right? we are studying the defects of eye. Can you see the screen? Can you see the screen?
Yes, sir. Yes, sir.
Okay. So, the two defects I have already discussed. Myopia I discussed, the reason as well as the corrective measure. How can we rectify that? Using concave lens I discussed. And hypermetropia, the corrective measure, everything I discussed. Then third eye defect is presbyopia. This is due to the aging. Okay, aging. Aging means the aged person has this kind of defects. The aged person. What happens if the person is too aged? I mean, like 75 years old or 80 years old. What happens is the flexibility will be very less. The islands, you know that above this islands there are ciliary muscles. Understood? I mean, before that, let me explain. This is not flexible. Islands is not flexible. You know that it should be flexible. Why? The island should be flexible because you know that in order to see the nearby object and far objects, we must be in a position to see the nearby object as well as the far object. This lens should be flexible. Flexible means it must have the ability to adjust the focal length. Understood? Sometimes it should be thin, sometimes it is appeared to be thin, sometimes it is appeared to be thick. Understood? Depending on the position of the object, the thickness of the eye lens should be adjusted. Then only we can see the nearby object and far objects. For the aged person, that flexibility will be lost. So understood? Clear. It is not flexible. Okay, it will be I mean, it can adjust a little bit. Okay, the eye lens can adjust the thickness a little bit but not so much flexible. As a result, such aged person will not be able to see the nearby objects as well as the far objects. Nearby objects will not be able to see, as well as the far objects also find it very difficult to see. What is the reason? Because of the flexibility of the eye lens. Understood? Just like a rigid object. Understood? Rigid means it cannot expand. Understood? Like that. So for the aged person, I will show you that slide. This one I finished. So for the aged person, the power of accommodation of the eye decreases with the aging. The aged person, flexibility of the eye lens is lost. They find it very difficult to see nearby objects as well as the far objects. Sometimes, normally, that word is not given in textbook, but you may write it. You may include that. They find it difficult to see nearby objects and normally the far objects. So you understood. So they will be using a different type of glass. Have you seen this kind of glasses? The aged person will be using a special type of glass. Special type of glass. I mean, in the bottom you can see a separate space allocated. Have you seen this type of glasses anywhere? The aged person use this kind of glasses. Have you seen? Please respond. Nishit, Lina, Samriddhi. Have you seen this type of glass? Glass means it's full of glass. This is full of glass, but there is a separate section. There is a small section allocated at the bottom of the glass. Both of them are glasses. You are not responding. Have you seen this type of glasses anywhere?
No, sir.
Yes, sir.
No. Who has not seen?
Lina.
Lina. Lina, you have not seen. I cannot see the picture right now. See, There is actually glass. I cannot draw the diagram. The actually for the other person, not for aged person, this is full of glass. Understood? Same type of glass. This is same type of glass is there, but for aged person, the full of glass, but the what happens is the upper portion is one kind of glass, the lower portion is another kind of glass. Understood? The upper portion and lower portion will have a different type of glasses. So I will tell you the reason. In order to see what's the nearby objects. For example, this person want to read the newspaper. Suppose this person has to read the newspaper. I mean, he want to read the nearby objects. Reading newspaper means he want to read the nearby objects. He has to read the newspaper using this space. Through this glass, he has to read the newspaper. Through this space, he has to read the newspaper. But if he want to see the far objects, he has to go through the other space. Through this glass, he has to watch. Okay, I hope you have understood. So there are two types of glasses. Understood? This is one kind of glass. I mean, thickness of the glass may be different. This is one kind of glass, and this one, the bottom side, is another kind of glass. So to read the far objects, to look at the far objects, he has to watch through this glass, the upper glass portion. And if he want to read the newspaper, he has to go through this space, through this glass, bottom glass. Understood? So because he has a difficulty in reading the nearby object and far objects, the intermediate, okay, no problem. But the nearby object and far object, they find it very difficult to watch. So they need both concave and convex lenses. Okay, they need both concave and convex lenses. The upper portion is used to see the far objects. Upper glass is used to see the far objects. It is what kind of glass? It is concave lens. Concave lens. The lower portion is just to read the nearby objects. It should be convex lens. So, understood. Some portion of the glass is concave lens. The remaining portion of the glass should be convex lens. So, this kind of glass they have to use. Understood? So, bifocal lens, we say that this as the bifocal glasses or bifocal lenses. Bifocal lens. I have not written that sentence. You please add it. The person who has the presbyopia must use a bifocal lenses. Bifocal lenses means two focus. Concave lens has one focal length, convex lens has another focal length. That is why we call it as bifocal glass or bifocal lens. Okay, so bifocal lens is the corrective device, not device, the corrective measure. Okay, for those person who are having presbyopia. So only this much note you have to write. Okay, that's enough. Okay, no more theories mentioned in the textbook. So presbyopia you understood, age-related issue. The flexibility of the eye lens is lost. Understood? Flexibility is lost or power of accommodation is lost. They find it very difficult to see the nearby object as well as normally far objects also. So though they must use bifocal glasses. I hope you have understood. All of you may draw this diagram. Okay, then you will never forget it. Nishit, Lina and Samriddhi, you please write down. If you are 100% clear, raise your hand. 100% clear. Samriddhi understood. Nishit understood. Lina, you can ask me doubt. Lina. Lina, you understood. Completed also. Okay. So, don't forget it. I explain everything in detail. Here the diagram is not given in textbook, only this much theory is sufficient. Presbyopia. Next is refraction of light through prism. Next heading is, write down. Next heading is refraction of light through prism. All of you please write down. Have you heard about prism anywhere in lower classes? Have you heard about prism anywhere? Prism? Lina, Samarthi. Prism is nothing but it is a glass. I mean it is a glass look like a triangle. Understood? It is full of glass. This is said to be prism. It will have thickness. Understood? This one has thickness, but I cannot show everything in detail. Understood? A glass which look like this triangular shape. A glass having thickness and look like a triangle is said to be a prism. The prism has a lots of applications. I will explain every applications later. Before that, we have to learn the refraction of light through prism. There are applications for prism. The lens and its application we have already studied. The lens is used to what happens, it is the corrective measures for those people who are having the eye defects. For that purpose we are using lenses, and prism is used for another purpose. I will teach you later. So this is the triangular shaped object, glass. Transparent material is said to be prism. So let us look at the refraction. Let me explain this. If you don't understand anything, I will repeat. You have to ask me. I don't want to show this thickness. Okay. It is a glass, look like a triangular shape. Okay. Suppose there is a light coming like this. A light is coming like this. I will explain everything in detail. Listen carefully. Okay. Listen carefully. There is a light falling upon one surface of the prism. This is full of glass. Understood? So don't think about the reflection. The light will enter into the glass. Understood? The light, no reflection. The light actually enter into the glass. You understood? So that is said to be refraction. The refraction we have already studied. Here at this point we are drawing a normal, or it is said to be perpendicular. Understood? Perpendicular is 90 degree. Understood? You can enlarge it. You may enlarge it. So we assume that the line, the light ray may be going like this without any deviation, but definitely there will be deviation. We studied in the previous classes. The light is entering from air to glass. If the light is entering from air to glass, what happens is the line will be bending towards the normal like this. There is a small bending. Instead of going like this, it will be bend. There will be a small bend towards the normal. Normal is this normal. Okay. There is a small bending. I will repeat, but let me explain this. Let me complete it. Here, let me draw one more normal. Let me draw one more perpendicular 90 degree. We expect that the light again will be going straight. No. We studied already that glass to air. Higher refractive intensity to lower refractive index. Understood? Denser to rarer. Denser to rarer. Moving away from normal. Moving away from normal in the refracting side. Going like this. Instead of going like this, it will be moving away from the normal in the refracting side. This thing we have already studied. So the light once enter into one face of the prism, it will bend towards the normal. Again bending like this. So this process you understood? Clear? Till this step you understood? Samriddhi, Nishit, Lina, you understood. I will show the enlarged diagram. Don't worry about that. I will show the enlarged diagram. You can expect one question based on prism. Okay, you can definitely expect one question based on prism. Normally what they ask is, they will the question will be like this: draw the prism and show the following terms in the diagram. The question will be like that. So I will explain each and important terms associated with the prism. Maybe some 3-mark question will be the based on prism. So the diagram, normally they ask diagram. Okay, so the each term you have to understand. Okay, you understood why they are deviating, because of the refraction. So listen, if the prism was not there, suppose if such prism was not there, this incoming light, all of you please listen, this incoming light, initial ray, is supposed to move in this direction. If the prism was not there in that place, understood? You agree with me? The incident ray is supposed to move along this dot line. Is that correct? Understood? Is supposed to move in this direction. If the prism was absent here, is that okay? Understood? But since the prism is placed, there is a bending taken place twice. Twice bending taken place. One bending is taken place inside the prism. The another bending is taken place outside the prism. Twice bending is taken. So there is a net deviation. There is an angle of deviation. Okay, so I will explain each and every term. I have a larger diagram. So there is a, you can see that there is a deviation. This is said to be a deviation angle. I will show, don't worry, I will show you the neat diagram. If the prism was absent, the light ray is supposed to move along this dot line. Because of the prism, that light is deviated and passing through this path. So there is an angular difference. This is the angle of deviation. Understood? Angle of deviation I will show in the another diagram. You need not draw it. I will show you another larger diagram. Okay. So this diagram, definitely they will ask, and they will ask, the question will be like this: draw the detailed diagram of the prism and show the following points in the diagram: incident ray, angle of prism, angle of emergence, like that. So let me explain. I think you understood the first part. You understood. This is the incident ray. This is the incident ray. The normal is drawn NN dash. NN dash is the normal at the point of incidence. The refraction, rarer to denser. The light is entering from rarer to denser, bending towards the normal. I discussed already. And here the light entered into the boundary of two mediums. Now it is going to move from denser to rarer. Denser to rarer. The normal is drawn there. Move away from the normal, going like this. This is the path of the light. In this diagram, NN dash is the normal in the incident position, and MM dash is the another normal in the emergent position, final position. NN dash normal, MM dash also normal. Let me explain everything. After that you can ask me doubt. Let me complete it. So you have to mark all these points. PE, the point name is not so important. Okay, instead of PQ, if you write XY, no problem. Okay, the letter is not that much important. Okay, don't worry about that. PE, can you see PE? You can give any name, no problem. PE, can you see that? PE is the incident ray. Hello, Samruddhi, audible? Samruddhi?
Yes, sir.
Okay. So, you understood, Samruddhi?
Yes, sir, understood.
PE is said to be incident ray. I have written below the diagram. PE is said to be incident ray. This one, PE. EF is the middle one. EF, can you see that? EF is the middle one. That is a refracted ray. Simply said to be refracted ray. FS, the third one. Can you see that? FS, the last one, FS, the light FS. It is said to be emergent ray. So the first ray is said to be incident ray. The next one, this portion is said to be refracted ray. Then final ray emerging out of the prism. The final ray is said to be emergent ray. The prism corners denoted by ABC. Normally we use that letter ABC, prism. There is an angle at A. Is that correct? There is an angle at A. That angle A is said to be angle of the prism. Remember this top angle. Remember the top angle is said to be angle of the prism. And there are other angle also. I told you about the normal NN dash. In the incident side, I have drawn a normal NN dash. The angle between incident ray and normal. Is that okay? Angle between incident ray and normal is I. I is angle of incidence. You will never forget it. The angle between incident ray and normal is angle of incidence, I. R is angle of refraction. You will never forget it. Angle between refracted ray and normal. This side, okay? This one has no any meaning, okay? Not mentioned. The angle between the refracted ray and normal is R, angle of refraction. The final angle between the emergent ray and normal. Angle between the emergent ray and normal is E, angle of emergence. So what I am saying is, if the prism was absent, the incident ray is supposed to move along this path, this red colored path. If the prism was absent, the incident ray is supposed to move along this path. This emergent ray, this deviation is happen only because of the prism. So let me extend this emergent ray just backwards. Let me extend the emergent ray just backwards. You can see one angle here, D. Can you see that angle D? So the incident ray is supposed to move along this path. Through this much angle there is a deviation happens. Understood? The incident ray is supposed to go along this way, but through an angle D there is a deviation. So D is nothing but angle between incident ray and emergent ray. Angle D is the angle between the direction of the incident ray and emergent ray. D is said to be angle of deviation. All these terms you have to understand. All of you please draw this figure neatly. Neatly draw this diagram and mark all these points. Nishit, Lina, Samruddhi, have you understood? If you don't understand any term, please ask me. Samruddhi understood. Okay, all of you please draw this diagram again neatly. Have you drawn the diagram? Lina, Samruddhi,
Yes, sir.
Nishit,
Yes,
drawn.
sir.
Okay. Again, I am telling you this diagram is very, very important. Next is the another property of the prism. And let me tell you one important point. Here I am using a particular colored light, for example a red colored light or yellow colored light, like that. Okay, The light having a specific color, understood? A single colored light. I will tell you the reason later. A single colored light means, for example, I am using a red colored light. If I use the normal light, I mean white light, normal light, let us call it as white light. There is another property. There will be another phenomena. I will explain it next section. For the time being, you just memorize like the thing like this. I am using a single colored light. For example, red color, or for example, green color, like that. Okay. Suppose instead of single colored light, if I use the normal light, for example, normal sunlight or the light coming out of the torch, understood? The normal light if I use, what happens? You can see another phenomena, I will tell you. For single colored light, this is happening, okay? If you use a normal light, just like a white light, sunlight is, we can call it as white light, or light coming out of a torch or mobile, we call it as white light. If I use white light, you can see another phenomena I will discuss. All of you please listen. This is the prism. This is the white light. For example, a light coming out of sun. Sunlight is white light. If the white light is coming like this, what happens is, yes, this procedure is happening. This thing is happening. The two times bending is taken place. First time bending, second time bending. Two stages of bending is there. But along with that, along with the bending, you can see that there are plenty of colors. The emergent ray consists of 7 colors: red, orange, yellow, green, blue, indigo. Indigo is similar to violet color. It is a color lying between blue and violet. Okay, look like violet, indigo and violet. So the final emergent ray consists of 7 colors of light if I use white light. But if I use a single colored light, such thing does not happen. I mean, if the red color is coming, the red color is going out. If green color is coming, the emergent color is also green. No different colors happens. But here, if I use the white light, 2 stages of refraction take place. Along with that, another phenomena take place. 2 stages of refraction means white light coming like this. First time bending take place. The second times bending is taking place. In the later stage, what happens is we get 7 colors. This is said to be dispersion of light. This phenomena, I will tell you the reason. This phenomena is said to be dispersion. Dispersion meaning is dividing. Dispersion meaning is dividing. Dispersion of light. I will repeat, don't worry, I will repeat. Dispersion of light. So dispersion of light is nothing but it is dividing the white light into its own components. White light, from this experiment, what we can say is white light is obtained by combining these 7 colors. If these 7 colors are combined together, it looks like a white light. For example, sunlight consists of 7 colors: red, orange, yellow. Everything is present in the sunlight. If the sunlight is passing through the prism, the component will be divided like this. So the order is very, very important. Violet denoted by the letter V, indigo denoted by the letter I, blue denoted by B. You studied in the lower classes, I know that. Green is denoted by G, yellow is denoted by Y, orange is denoted by O, red is denoted by R. If you read from the bottom, if you read the colors from the bottom, it is appeared as the word Vibgyor. Vibgyor, but you have to read from the bottom. So from this experiment, what is our conclusion? The white light, for example sunlight, consists of 7 colors. if it is passing through the prism, what happens? It will be divided into 7 components. Okay, understood. So all of you just draw a rough diagram. You cannot show that the colors. Instead of that, you may draw a rough diagram like this. I will show you. You have to write white light here. You may draw like this. Okay. Rough diagram, only rough diagram is needed. Okay, or you may take the screenshot. This coloring is not required, don't worry, coloring is not required. You may and also please don't forget to mark V I understood B G O like that. Okay, you please draw the diagram. Okay, understood. The color you need not mark, just draw a rough diagram, that's all. Just draw a rough diagram. In exam, if they are asking for dispersion, you have to draw this rough diagram without using any color, but you have to mark the components V, I, B, G, O, Y, O, R. And remember, the definition is very simple. When the white light is passing through the glass prism, it will be divided into 7 component colors. 7 component colors. It is that process is said to be dispersion. When the white light is passing through a glass prism or simply prism, it will be divided into 7 of its component colors. Vibgyor. This phenomena is said to be dispersion. All of you please write down, draw a rough diagram. If you have finished, please raise your hand. If you don't understand anything, please ask. Samriddhi completed. Draw a rough diagram. No need to color anything. Okay. I told you rough diagram. I explained about the drawing rough diagram like this.
Sir,
Yes, tell me.
sir, I learned it as Roy G. Bill.
Okay. If you studied in that way, no problem. No problem in that. Okay.
Okay, sir.
You studied in 8th or 9th standard, right? But this diagram was not given. I think so. Right? This diagram was not there in that textbook.
Yes, in 8th standard.
Yes, 8th standard. Only rough diagram to be drawn. Okay. The 7 colors combined together, we get white light. If you have written, please raise your hand. Lina, Samriddhi, Nishit completed. So, the dispersion of color white light is okay. The next is rainbow. Look at this diagram. All of you please listen. Rainbow. You studied the theory a little bit in the 8th standard. I think so. when the rainbow is formed. Is the rainbow formed every time? No, there is a condition. Okay, if certain condition is met, then the rainbow will be formed. Can you suggest what is the condition for the formation of rainbow? Anybody? Can you suggest? Samriddhi, Lina, Nishit. The condition necessary for the formation of the rainbow.
When there is water droplets in the sky.
Ah, yes, yes, yes. I will tell you. I will tell you. So the condition is very simple. Listen. The rainbow is generally formed in the morning session or in the evening time. Okay, morning time or in the evening time. In the daytime, for example, 12 p.m. or 1 p.m., no rainbow will be formed. In the morning time, like 7, 7:30, like that, or in the sunset time, understood, around 5 p.m. for understood, 6 p.m. like that. So in the sunrise time or sunset time, the rainbow is formed. The condition is, suppose this is earth, I am standing here. Okay, I am standing here. Okay, earth I don't want to show. I am standing here on the ground. I am standing here on the ground. And here there is a sun. So for example, sunrise time. Okay, sunrise time. This is the sun. And cloud, this is the cloud. There should be cloud. Okay, water droplets must be there. Okay, the normal cloud is not. I am not talking about the normal cloud, this white color, not white color, the cloud which contain water droplets. Okay, the cloud must contain water droplets. So in this situation, the rainbow will be formed. I will tell you the reason. This cloud contains water droplets, right? Let me draw the enlarged diagram. Let it be the water droplets. That diagram, yes, it is given in the textbook. Okay. So what happens is, and I am standing on the ground. Okay, I am standing on the ground. So what happens is, the sunlight is coming like this. I will show you. The sunlight is coming like this, and it will enter into the water droplets. You can zoom it if it is not visible. The light rays coming like this, and it undergoes a refraction, entered into the water droplets. After that, it will undergo reflection. I will show in the next diagram. I have already marked the diagram. So sunlight, sun is in the left side. Sun is in the left side. I am standing in the middle. I am standing here. I am standing here. Sun is in the here, left side. Sunrise time. The cloud is in the right side. The cloud should be in the right side. Sun is in the left side. And I am standing between sun and cloud. The sunlight is coming like this. The sunlight undergoes refraction, entered into the light. Just a normal is drawn. Small deviation happens. Remember, as a prism, it's very similar to prism. A small deviation happens from the beginning itself. From the beginning itself is it will be divided into 7 colors, but the deviation is too less. I mean, the upper portion is red and the bottom portion is violet. You know that the red has got the minimum deviation, violet has got the maximum deviation, right? So I will use the red and violet. Okay, I will write here. I think that I will write here. The red has a less deviation, violet has the maximum deviation. This water droplets, the starting point is very similar to prism. Like, look here. Understood. Once the white light enter into the prism, immediately the deviation starts. Immediately the dispersion starts. The upper one is red, the bottom one is violet. So here, once the light enter into the water droplets, from the beginning itself the deviation starts. The upper portion is red, less deviation, violet has maximum deviation. And This two colors between there are indigo, yellow, everything is there, and it is going to hit this boundary. Still it is water boundary. Okay, another phenomena take place. Once this red to violet color hit this boundary, another phenomena take place. Its reason you will learn in the higher classes. This is reflection. It is a special feature. You will learn the reason in the higher classes. This reflection is said to be internal reflection. You are expecting that the light will escape. You are expecting that the light will escape. No, if the light is falling on some specific angle, if the light is falling upon some specific angle, it will undergo reflection. It is a special phenomena. It is said to be internal reflection. You will learn the condition for the internal reflection in the higher classes. The light will not escape, but instead of that, it will internally reflected. So red color is reflected going like this, violet color reflected and going like this. So this is red and this is violet, and this red color escape from the water droplets. Violet also escape, I mean refraction take place, refraction. So this is red and this is violet. So this is the thing. Okay, so in the rainbow formation, first there is refraction. First stage there is refraction here. Refraction along with the dispersion, R to V, right? Refraction plus dispersion. These two things simultaneously happens. Dispersion. In the second stage, total internal reflection. That phenomena you will learn in the higher classes. Total internal reflection. If the light is falling upon some specific angle, no refraction, only reflection take place. After second stage, the third stage, emergent ray, the refraction. So if I stand in the ground, I can see red to violet. All the colors I can see appeared as the rainbow. So you please draw this diagram. No need to draw a neat diagram. You need not show all these colors. This diagram you please draw, only a rough diagram. Okay, and the three stages you please write down. And if you don't understand anything, you please ask me. If you don't understand anything. Lina, do you have any doubt? Everyone is okay? Understood. Rainbow formation is clear.
Yes, sir.
Okay. I think this twinkling of stars, advanced sunrise, scattering. Only these three topics are remaining. These three topics, twinkling of star, discussing twinkling of star take time. Okay, I have to draw some neat diagram for that. I need a continuous class. I mean, in 30 minutes, I can complete this chapter. 30 minutes time, I can complete this chapter. This chapter will be over. Twinkling of star, advanced sunrise, delayed sunset, scattering of light. Only these three are remaining in this chapter. All other things we studied. Okay. So I think it is better to wind up the class right now. Okay. So
Thank you.
okay then. Bye.
Thank you.
Thank you, sir.
Okay then.